Hello dear students, today we are going to deal with vector diagrams or vectors, okay, from IGCSE or O-level physics. So let's dive deep into that. First I'll explain about the concept. Then we have few past paper questions, nearly 17 questions that we are going to solve one by one. Okay. Now first, vector diagrams, okay, are used, okay, vector diagrams are used to find the resultant between two vectors, two or more vectors, but here in IGCSE only two vectors, okay, only two vectors. Those two vectors are perpendicular to each other. So the revised syllabus, they have said two vectors should be perpendicular to each other. So vector diagrams are used to find the resultant vector, okay. We use two methods to find. One is triangle method, and second one is parallelogram method. Okay, and we also use Pythagoras theorem, okay, if we are going with trigonometry, okay, Pythagoras theorem. And also little bit of trigonometry we use, cos, sine, all these things. Okay, now what is triangle method? First of all, for example, assume that we have a ball, okay, we have a ball, and this ball is subjected to two forces, okay. One person is giving force like that, other person is giving force like this, okay. So if they ask you where this ball will be going, okay, and these two forces are acting perfectly 90 degrees to each other, okay, the angle between two forces, let's say this is force A and this is force B, how it will be moving? So we will say that it will be moving somewhat like that, okay. By our just common sense we can say that it will be moving in that way. So this will be the result of A and B vectors, right? A and B vectors. So this will be the result of A and B vectors, and if you want to know the direction, okay, we can use tan theta for that. That is opposite by adjacent, A by B we will use here. If you want precisely what is the theta, then tan inverse of A by B we should be doing. Okay, yes. Now what is triangle method? What is triangle method? So let's say we have a force A here, so that I am just copy and pasting, okay, that we have to take. Then force B, again I am copy and pasting that force B, yeah. The head of the second vector should meet the tail of the first vector, or tail of the first vector should meet the head of the, or tail of the second vector should meet the head of the first vector. So we have to meet it like that, okay. Like somewhat like that, it's not exactly meeting, but anyways, so it should meet like that, okay, perfectly. Okay, if I do that, yeah, fine, somewhat like that. Then the result, okay, will be head should meet the head and tail should meet the tail. So I'll take vector itself. So it will be like that. This will be the resultant. So this has to be here, exactly here. And this one will be there. And this is somewhere here. And this one will be here. I have to extend a little bit, okay. So if you measure this one, okay, if you use the scale diagram, okay, let's say that you have taken, this is 5 newtons, each newton is 1 centimeter, this is 4 newtons. So here you can draw 5 centimeter line. Here you can draw 4 centimeter line, perfectly vertical and perfectly horizontal. The result should, you have to start from here and end there. So if you measure that, you will get. Or you can go for Pythagoras theorem for this one. So that will be root of a square plus b square. So in this case, it will be root of 5 square plus 4 square. Okay. So if you do that, you will be getting the answer. So root of 5 square plus 4 square will be 5 square plus 4 square. That is root of 41. So which is approximately 6.4 centimeter. Or if I want to convert, this will be 6.4 newtons. 6.4 newtons. If you want to measure the theta, directly you can use the protractor, okay, and measure the theta. And if you are measuring this theta, then that will be to the horizontal line. If you are measuring this theta, then you have to mention that that is to the vertical line. Let's say this is theta 1, theta 2. Theta 1 if you are taking, then it will be to the horizontal line. This is the horizontal line. And theta 2 if you are taking, that will be to the vertical line. And similarly, the parallelogram method also, okay, used to find the vectors. Okay, in that one we have to keep both the vectors. Let's say this is my a vector, okay, and b vector I should keep like that, and parallel to a vector I should draw one more vector there, and parallel to b vector I should draw one more vector here. Okay, one more vector here. So let's take this off. Okay, parallel to this vector I should draw one vector, parallel to this vector I should draw one more vector like that, and the result, okay, result will be like that. This will be my resultant. Okay, so simply I have to measure. If I use the scale diagram, okay, if I mention that 1 centimeter is equals to 1 Newton or 5 centimeter is equals to this many Newtons, accordingly I should draw the scale diagram, then I have to proceed. Okay, so these things you have to remember about the vector diagrams. These are the concept of that. And now we have few questions that we will try to do one by one, which is very easy. So now first one, we have a 3 Newtons force in vertical direction, 4 Newtons force in horizontal direction. What could be the result of this one? So if you see the options A, B, C, D, clearly you think logically. Okay, if I keep a ball here, okay, if I keep a ball, one boy is hitting like that with 3 Newtons, another boy is hitting like that with 4 Newtons, definitely the ball will go somewhat like that. Okay, so the result, okay, of these two will be in that way. So we have to go for A option. Okay, B, C, D is totally illogical. Okay, A is the apt answer for that one. Okay, if they ask what is the magnitude of that R, then we have to use the Pythagoras theorem. So if this is R, so I will just use R is equals to root of 3 square plus 4 square. So 3 square will be 9, 4 square will be 16. So root of 25, which is equal to 5 Newtons. 5 Newtons. If they ask what is the angle here, okay, to the horizontal, then I will go for tan theta, that is equal to opposite. Opposite is 3 and adjacent is 4. So tan theta I have to use, that will be equal to tan inverse of 3 by 4. Okay, so if I do that with the help of a calculator, I have to press shift for that. Tan inverse of 3 over 4, that is giving me, tan inverse shift, tan inverse of 3 by 4 is giving me 36.86 degrees. So this angle is approximately 36.86 degrees. Okay, I hope you have understood this question very well. Next question, okay, a body is there, or 4 forces are acting at this point or a body, and what is the size of the resultant force? So here we have to first resolve in x and y direction. See, if you see the y direction, 2 and 2 both are equal and cancelling out. Only we have in horizontal direction, we have difference in forces. One is 8 newtons, other one is 4 newtons. So this side I have 8 newtons and the other side I have just 4 newtons. So I will do 8 minus 4, which is 4 newtons. If they ask what is the direction, towards the left I have to select. So now only 4 newtons I will select. Okay, yes. Next question. I have two forces, one is 9 Newton, 12 Newton. What is the magnitude of that? For magnitude, I will use Pythagoras theorem as I said. So R will be equal to root of 9 square plus 12 square, right? So if I use the calculator for that, so root of 9 square plus 12 square, that will be 15. Okay, so R will be 15 newtons. And in what way it will go? So logically, if you think that if I keep a ball, one person is hitting like that and other person is hitting like this simultaneously or at that instant, the ball will tend to move somewhat like that. Okay, so the resultant will be in the direction of O and Q and the magnitude is 15 newtons. So go and select A option. A option, OQ, and it should be 15 newtons, right? Okay. Next question. This is from the latest IGCSE paper, I remember 2025 or 2024, latest paper only. So here I have a 6 Newton force upward direction and 9 and 1 Newton in that direction. So if you think like that, so this is the box for example, okay, somewhat like that, and 9 minus 1 will be 8 Newtons here, okay, and 6, and there is no downward force, so 6 Newtons there in upward direction. So what is the resultant magnitude? Magnitude means value, size. Okay, if they ask, so I will go for Pythagoras theorem. So 6 square plus 8 square. You can write 8 square plus 6 square. That is also fine, no problem. So then I will go for 6 square plus 8 square. That is equal to 10. So 10 newtons will be the result. So B option will be the right answer. Okay, next question. Here I have three forces, 11 Newton, 3 newtons, 2 newtons. 11 is acting totally towards right, 3 is acting towards left, and 2 is also towards left. Which additional force will produce a result of 3 newtons to the left? Okay, so now if you see in left direction I have 5 newtons. In right direction I have 11 newtons. Resultant should be 3 to the left. Okay, so what I should do, okay, 14 I should get somehow. Okay, 14 I should get somehow. So if I add 9 newtons to the left, okay, 9 plus 5 will be 14 newtons. 14 minus 11 will be 3 newtons to the left. So 9 newtons to the left I have to select. I have to add that so that it will be giving you the result of 3 newtons towards left. Next question, which object has the largest resultant force? If you see a 30 and 10, 10, 20. So in this case, the resultant will be 30 minus 20, which is 10 newtons in right direction. Here it will be 10 newtons in right direction because 110 and 110 will be cancelling. 5, 5, 30. So 30 minus 10, which will be 20 in the left side. And here 5 plus 5 plus 5 is 15 only in left side. So I have to go for C. That is the largest resultant force, 20 towards left. Direction does not matter. The value only matters here. Okay, 20 is the largest number. So I'm going to select that. Okay. Seventh one. Again, 3 and 4 newtons we have. Okay, 3 is acting like that, 4 is acting like that. Resultant will be like that. If you use a football, one person is kicking like that, one person is kicking like this, it will be going like that. Okay, so C will be the right answer. According to parallelogram method also, 4 is like that, you draw a 4 newtons line there. 3 is like that, you draw a 3 newtons like that, and the diagonal which is passing and the heads are meeting at that one point, that will be the result. That will be the resultant. Next question. Which diagram shows the addition of 4 and 3 forces? Okay, so 4 and 3, if you add, definitely you will get 5 because already we did that. Okay, so 4 square plus 3 square. Okay, if you take the result of this one, you will get 5 newtons. But what is the direction? 3 is upwards and 4 is left side. So if you keep a ball, one person is hitting like that, other person is hitting like, ball will tend to go like that. Okay, but here this is wrong totally. Okay, so next one, if you see this option, one second, yeah, so 3 newtons. Okay, I think A will be the right answer. So 3 newtons, if I use the parallelogram method, okay, I have to parallelly draw a line of 3 newtons here. Okay, so this will be 3 newtons. I should draw a parallel line of 4 newtons in that way. Okay, this will be my 4 newtons. Okay, all the heads should meet at one point. Okay, so that's the rule of parallelogram method. Okay, that's the rule of parallelogram method. Or triangle method also, the tail of the one first should meet the head of the next first, and the diagonal, head should meet the head, tail should meet the tail. That's what I said. So A will be the apt answer. A will be the apt answer. B is also wrong. Okay, the arrow should be upwards, and D is also wrong. Head and head is meeting. That is not correct. Okay. Now 3, 4, the resultant will be 5, and along OY. Okay, OY is the answer. How 5? Because we did in the previous question with 3 and 4. Now this is also from the latest paper. What is the resultant first? If I have F1 and F2, let's say F1 is acting in this way, F2 is acting in that way, the resultant will be in between, R. So for that I use Pythagoras theorem, root of F1 square plus F2 square. Not separate roots, but together root with individual squares of each forces. So A will be the right answer. Next question, again 3 and 4. Okay, the resultant will be like that. Okay, the resultant will be like that. So if I just want to place here, this I have to place there. Even if you measure it, it will be coming perfectly as 5 newtons. Okay, if it is a proper grid and proper, it is given in proper centimeters. So this will be 5 newtons. How 5? 3 square plus 4 square, as already stated, that will be equal to root of 25 will come. Root of 25 is 5. So go for option B. And direction, if they ask, this is the direction. Okay, now this question. Okay, a ship travels due north. Okay, so this is the north direction. So there is a ship. Okay, I'm just drawing in short way. It travels towards north, students, at 20 meters per second. Okay, ship direction should be towards north, and it enters a channel where the current in the water is from west to east. So water, okay, water, it is hitting, okay, or water current, it is hitting from west to east like that. So what is the magnitude of that? Speed of the water current or current is 20. Okay, 20. This is also 20, that is also 20. What is the resultant velocity? So if the ship is going towards north and constantly the water is hitting from west to east, the ship will tend to move like that. Okay, tend to move like that. So this will be the new velocity. If they ask what is the velocity, then root of 20 square plus 20 square will come. Okay, that will be the resultant velocity. So if I go for that, 20 square plus 20 square, that will be 28.28 meters per second. If they ask what is the angle, exactly 45 degrees, because same magnitude we have. So this is the velocity of the ship or the direction of ship, and this is the direction of water current. And if you use the parallelogram method, it should go like that. So C will be the perfect answer. C will be the perfect answer. Okay, next one, this is a simple question. There is a block which is on the flat surface. Two forces are acting, 4 and 3. What is the result of this? 4 minus 3. In which direction? It will be towards right. B is the right answer. Okay, now this is a little bit of calculation type. It's not MCQ, theory question we have here. So one force is acting in this way, other force is acting in that way. What is the result of these two forces? So the result will be somewhat like that. Okay, in this way. Okay, in this way, the resultant force will be. So I'll just keep exactly here. Okay. So how to find the resultant? Again, simple. Root of the horizontal force square plus the vertical force square. So 0.74. Fine. Okay. So now if we take calculator, 0.40 square plus 0.74 the whole square. If I do that, I'm getting 0.84. Okay. So make sure that it is according to the significant figures given in the question. Okay. So this is the result. If they ask what is the angle to the horizontal, okay, to the horizontal, okay, theta h I'm writing to the horizontal, then I will go for tan theta. Okay, that will be opposite of this one is 0.74 and adjacent of that one is 0.40. So theta h will be tan inverse of 0.74 divided by 0.40, right? Okay, so now shift tan 0.74 divided by 0.40. So if I just click, I get 61.6 degrees, approximately 62 degrees. I have to mention to the horizontal, or to the horizontal, that will be fine. That will be the direction. Okay, if you are taking this angle, then opposite will become that and adjacent will become this one. Then it will be like tan theta will be 0.40 divided by 0.74. Then you have to mention to the vertical. It will be exactly 90 minus 62 or 61.6, right? 61.6 exactly it will be. So you have to be very careful with that when you are giving the direction, right? Okay, next question. Here, one second. There is a boat that crosses a river bank. Okay, so I'll just take this photo little up. No, not able to take a. Sorry, somewhere it is there. Okay, anyways, the boat is going up, okay, between two river banks, okay, and the water current is hitting like that. Okay, the river current acts at right angle direction of boat. The river current has the speed of 2.5 meters per second, and the boat travels at 3.5 meters per second between the river banks. By scale diagram or calculation, determine the speed and direction. See, I cannot draw with the scale here because I don't have scale. Okay, you can draw with scale diagram also. You have to take the scale. Okay, for example, 0.5 meters per second is equals to 1 centimeter. Then for 3.5 meters per second, you will take 7 centimeter line. For 2.5 meters per second, 5 centimeter line, and the direction should be perfect. Okay, so yeah, 7 centimeter line vertically you should draw. Okay, I'll draw with this one. 7 centimeter line vertically you should draw. Okay, so let's say this is 7 centimeter, and second one, head should meet the tail, that will be just 5 centimeter. Okay, so 5 centimeter line from here to here you should draw. Okay, this is approximations only, students. Okay, 5 centimeter line you should draw like that. Okay, and the head should meet the tail, and the result will be tail should meet the tail, head should meet the head. So it will be like that. If you measure this line, you will get the answer. Okay, if you measure that line, then you have to divide with 2. Okay, that's the scale we have taken. No, 0.5 meters per second is equals to 1 centimeter. Then 3.5 meters per second, that will be equal to 7 centimeters. 2.5 meters per second will be equal to 5 centimeter. Why you can't take just 1 meters per second is equals to 1 centimeter? The diagram will be too short and it will be very difficult for us to get the accurate value, or to draw also it will be little difficult. Okay, so here the result will be, obviously it will be greater than 7, okay, maybe 8.5, something like that, or you can go with the calculation. So r will be equal to root of 7 square plus 5 square. So 7 square will be 49 and 5 square will be 25. 25. Okay, so if I take that one, root of 49 plus 25, I am getting 8.6, okay, 8.6 centimeters. Okay, so this will be 8.6 centimeter. Then what is the velocity? I have to divide with 2. So that will be 8.6, right? So 4.3. Okay, 4.3 will be the velocity. 4.3 meters per second will be the velocity. If they ask what is the angle, then opposite by adjacent you can do. Tan theta, that will be equal to 7 by 5. Theta will be equal to tan inverse of 7 by 5. Okay. Now no need to divide, because anyways you will divide for this one and this one. So it will not make a difference. So tan inverse of 7 by 5. If I do that, I will be getting 54 degrees. So 54.4. So 54 will take. So this will be 54 degrees. Okay. Next question. And I have last 2 more questions only. Okay. Here I have a parachutist, okay, who is having a weight of 950 newtons and he is falling vertically at constant velocity. That means he has reached terminal velocity. At certain height, okay, the wind starts to blow, okay, and moves horizontally at a velocity of 4.5. So this is the wind velocity. Wind velocity. Now, and he continues to fall at this rate, that is 6.5 meters per second. Use a graphical method to add together the horizontal and vertical velocities to determine the size of the resultant velocities. Again, so what you have to do, scale you have to take first. So you have to mention 1 centimeter is equals to 1 meters per second. Then 4.5 meters per second will be 4.5 centimeter. Similarly, 6.5 meters per second will be 6.5 centimeter. So 4.5 centimeter line you have to draw first to the horizontal. Okay, because it is horizontal, right? So draw 4.5 centimeter line. Assume that this is 4.5 centimeter line. Here I have taken 1 centimeter as 1 meters per second because 4.5 and 6.5 is okay. Okay, it's not too small measurement. Okay, and then the next force, okay, then the next force is 6.5. Head should meet the tail according to triangle method. I'm going for triangle method. So here this will be 6.5 centimeter. Then the result will be head should meet the head and tail should meet the tail. So this will be the resultant force. You have to measure that. Okay, it will be definitely greater than 6.5, maybe 7.5. Okay, I can't measure here, so I'm using that Pythagoras theorem. 4.5 the whole square plus 6.5 the whole square. So if I do that, 4.5 the whole square plus 6.5 the whole square, that will be equal to 7.9 I'm getting. So R is equal to 7.9 centimeter you will be getting, or you can convert because 1 centimeter is 1 meters per second. This you can clearly say 7.9 meters per second. If they ask the velocity, if they ask the direction, then you can take this theta and mention to the vertical. Okay, mention to the vertical because from the vertical line only I have taken. So tan theta, that is equal to opposite by adjacent, which is 4.5 by 6.5. So theta will be equal to tan inverse of 4.5 by 6.5. So if I use the calculator again, tan inverse of 4.5 by 6.5, which is 34.69, which is 35 degrees. Okay, this value will be 35 degrees to the vertical. Finally, or you can use protractor to find the angle. Okay, yes, finally I have this question. I have 120 kilonewtons for this aeroplane upwards and 60 towards down. It is lifting up. That's the meaning. And forward thrust is 60 kilonewton and backward resistive force is 40 kilonewtons. So 120 kilonewton minus 60 will be 60 kilonewtons. Here 60 minus 40 will be just 20. So 20 I can draw like that. So if you see the result of this one, it will be like that. So this arrow only I have to select. If you want the magnitude, then root of 60 square plus 20 square you will be getting. So B will be the perfect answer here. So hope you have understood these concepts and questions. We will see you in the next video with a different topic. Thank you, students.